There are two basic statements in axiomatic design. They are called axioms, although they are not really axioms in strict mathematical meaning of this word. These are rather two criterion or two indexes or two properties that system needs to have if it is called good. We will focus mostly on the first one. And the idea is the following. First, we define what do we want from our system, what are system outputs. We call them function requirements. Second, we define what we can change in the system, what are inputs to the system that we can vary or can change. They can be external signals to the system, control signals, or they can be parameters we can change in the design. We will call them design parameters. Professor So noticed that the design is optimal from his point of view if specific design parameter can be adjusted to satisfy its corresponding function requirement without affecting others. In other words, the system becomes autonomous. It falls apart into a set of scalar direct interactions from design parameter to function requirement. This idea can be easily given a mathematical illustration, if you are not afraid of mathematics, of course. If we have a vector of function requirements and we have a vector of design parameters, then what is between them could be called design matrix, a set of functions, a set of numbers. And if the matrix is full, there are no zeros in the matrix, then unfortunately by changing any input parameter we will affect all output parameters. Then the design is called coupled. If the matrix is diagonal, each function requirement can be adjusted by specific design parameter independently. And then design is called independent. That is good. And finally, the third case, if the design matrix has a kind of triangular topology, upper triangular or lower triangle, then it is called decoupled. In this case, each function requirement can be addressed, but the design sequence should be correct. Here is a classical example of evaluation of two designs from this perspective. There are two water taps. Which one you like better? So function requirements are the same for both of them. We need water and we need certain temperature of water. So we need the flow of water and water temperature. But in the case of the first design, this kind of tap, the design parameters are vertical angle and horizontal angle of the handle. And the design matrix is diagonal. So the design is optimal or independent. And indeed, it's very nice from user perspective, isn't it? We can agree. In the second design, we have two valves, a kind of last century design. Design parameters are different, and there are left and right valves angles as the design parameters. Having rotated any of these valves, we can affect water temperature and the flow both. Then the design is called not optimal or coupled. The second axiom of Professor So can be used to compare independent designs. In other words, when multiple designs are found from axiom 1, then the best one could be found or chosen based on axiom 2. The best independent design is that one that requires minimal amount of information to be described. That's the axiom 2. My translation of this kind of academic statement to common sense language would be the simpler, the better. The amount of information could be amount of drawings, amount of text, amount of numbers, amount of information in Shannon sense that you need in order to describe the design. It can be quantified and carefully calculated, or the concept can be used in a kind of qualitative manner. Now let us, for example, compare three tab designs that are in the picture. They are all independent. Which one you like better? They all are nice. But it's hard to give a measurable evaluation of, let's say, information needed to describe them. How many drawings we need, how many parts of them. But maybe the left one has slightly better chances to be called the simplest. So it would be chosen as the most suitable in accordance to axiom 2. We cannot help pointing out that this second axiom actually seems to be really similar, have similar meaning to the concept of ideal final result from theory of inventive problem solving trees. The simpler, the better. Small amount of parts, small amount of elements, small amount of subsystems. So, how does it all work? So we get a device, a product, or an interface we want to develop to improve. We focus on the interaction of this product or interface with the user, with the client, or with the operator. We define what do user or operator want or has to control in operation time. And these are function requirements. Then we check what the control inputs are to the current design. So what we can change, what we can vary, assign, tune in the design to address these required outputs. And these are design parameters. If there is a crosstalk between the design parameters, if we are not able to control a specific output by single input, then the current design is coupled. That means it is not easy for user, for customer, or for operator to control the system. It is a message to ideate on how to change the design, how to invent a new design. And in a new design, the user or operator is able to control each output by single input. If we succeed, and if the design is found, and it's cheap enough, simple enough, it meets other design constraints, then there are really good chances that the boss will say, "Good job.